In lab number 8, we are going to use an acid-base titration to calculate the solubility product constant of calcium hydroxide. When a substance with limited solubility is placed in water, it dissolves until the rate of the backward reaction, aqueous calcium 2 plus OH minus ions, forming solid calcium hydroxide, is the same as the rate of the forward reaction, where solid calcium hydroxide breaks down into aqueous calcium ions and hydroxide ions. At this point, the solution is considered to be saturated. The equilibrium constant for the reaction can be calculated using this equation, Ksp equals the concentration of calcium 2 plus ions times the concentration of hydroxide ions squared. Remember that the reason for this superscript is because the coefficient 2 in the stoichiometric equation. And remember that we do not divide this by the reactants because the reactants are solid, so they are not included in the calculation. To calculate the equilibrium solubility constant, we need to know the concentration of the calcium and the hydroxide ions at saturation. We can determine the concentration of hydroxide ions by a simple acid-base titration with hydrochloric acid and bromothymol blue indicator. Before we titrate, we have to prepare a saturated solution of calcium hydroxide by dissolving solid calcium hydroxide in water until a white precipitate remains and does not dissolve further. You need to allow the precipitate to settle and then slowly filter the solution through filter paper to collect the solid free supernatant. The supernatant container then needs to be stoppered as soon as you're done filtering because the solution can react with atmospheric carbon dioxide to create a solid calcium carbonate, which is extremely insoluble, and this will throw off the results for your KSP titration. To perform the titration, we will use a 10.0 milliliter aliquot of calcium hydroxide supernatant and dilute it with about 50 milliliters of DI water and add a few drops of bromothymol blue indicator. We will then titrate it with 0.01 molar hydrochloric acid solution, which has been standardized for you, and you will use the same techniques as you would to carry out any acid-base titration. You will rinse the burette with HCl solution before you fill it, titrate a drop at a time, and swirl between drops as you titrate. At the equivalence point, the bright blue solution will turn bright yellow and will remain bright yellow. To get the most accurate results, you should carry out 3 replicates of this titration, and your data points should all agree within 5%. Now that we have obtained our experimental values, we can use them to calculate the solubility product constant. First, we need to use our values to find the concentration of OH minus ions in solution. Remember that the moles of H plus ions used in the titration is equivalent to the moles of the OH minus ions consumed. Since we used 0.01 molar HCl, the number of moles of H plus used can be found by multiplying our experimental values converted into liters here by the molarity, which is 0.01 HCl. The number of moles of H plus is equivalent to the number of moles of OH minus because it's a 1-to-1 stoichiometric equivalence. Finally, we can calculate the concentration of OH minus in each aliquot by dividing the number of moles of OH minus, which you simply found up here. So you're just going to plug that in right here. And then you're going to divide it by 0.010 liters because that's our 10 milliliter aliquot. You'll get 3 values, and then you should take the average of those 3 values and calculate the average concentration of OH minus to use in your final calculations. Once you've found the concentration of OH minus, you'll need to find the concentration of calcium 2 plus as well in order to calculate the solubility product constant. Because we have this right here, but we also need this. Because of the stoichiometry of the reaction, the molarity of OH minus equals twice the molarity of the calcium 2 plus. And you can see this in the reaction because for every 2 moles of OH minus, we have 1 mole of calcium 2 plus. So that means for every 1 mole of OH minus, we would need to have half a mole of calcium. So twice the moles of calcium is going to give us 1 mole of OH minus. So this means that our concentration, the calcium 2 plus, pardon my writing, this is not the most efficient method, is going to be equal to 1/2 the concentration of OH minus. Okay, and then we can plug that into the original KSP equation. The 1/2 OH minus times OH minus squared is going to give us this final equation, which is 1/2 times OH minus cubed. Then you can just plug in your average OH minus value, and then ta-da, you have your KSP. To analyze your results, you're given the literature value of the solubility product constant, which is 6.5 times 10 to the minus 6. And so we ask you to calculate the percent error, which is your experimental value divided by the actual value times 100. And I just want you to think about whether your experimental results are accurate or not. Once you've completely calculated it and you figure out what your experimental error is, normally anything within 5% is considered very good for experimental error, so keep that in mind. You will find an Excel template on Moodle, this one right here, which you will need to fill out with your values. You will also need to attach your calculations. The Excel sheet itself is not sufficient. You will be graded on whether you can show that you were able to do the calculations as well. You have 2 post-lab questions, which you will find on your handout. Number 1, what would happen to our results if we titrated with solid calcium hydroxide still in the titration solution, and why? And number 2, the solubility of barium sulfate at 298 Kelvin is 1.05 times 10 to the minus 5th molar. Calculate the KSP. Just as a hint, this is a 1-to-1 stoichiometric equivalence of barium and sulfate, so that might help you out for calculating this. Finally, for full credit, you need to submit your pre-lab notebook pages, just as if you were coming to lab in person, your filled out Excel sheet, your calculations for all your Excel data, and then your 2 post-lab questions. That will be it for this lab. Stay healthy out there. Enjoy the spring weather.